Good afternoon, everyone. Welcome back to the AeroCampus 2022, a virtual student outreach event by the Singapore Air Show. I'm Yu Hok from Science Center Singapore, and I'll be your moderator for this STEM chat segment. Before we start, I would like to remind everyone that if you have any questions relating to the sharing letters, please feel free to post them in the Q&A section. It is now my pleasure to present our two distinguished aviation professionals to share their valuable knowledge and experience with everyone. Here with me, we have Dr. James Wang and Dr. Neo Kok Beng. Our first speaker, Dr. James Wang, now teaches aircraft design and performance at Nanyang Technological University in Singapore and consults for companies in the electric vertical takeoff and landing industry. He has several executive leadership positions and has a remarkable 30 years experience in aerospace, helicopter, defense, and high-tech industry in US, Europe, and Asia Pacific. Dr. Wang will enlighten us on why electric power and private space launch are making right now the most exciting time to be an aerospace engineer. Dr. Wang, please.
Thank you, everyone. So let me allow me to share my screen, and I will make this a very fun presentation for the next 15 minutes. Okay, so the topic of my presentation for the next 15 minutes will be on why electric power and private space launch are making right now, today, the most exciting time for you to be an aerospace engineer. Okay, so currently I'm a professor. I teach aircraft design and also teach aircraft performance in aerospace engineering at the Nanyang Technological University in Singapore. Okay, so let's take a look, start the journey and have some fun. Okay, so back in the 1960s, there's a race around the world, especially between the United States and Russia, to see who will be the first one to go into space. So in 1961, so Russian became the first. So it's shown here, standing in the car, that's the Russian cosmonaut, Yuri Gagarin. He's just celebrated winning to become the first human to fly into space in April 12, 1961. Even though it was a very short trip, it only was 108 minutes and 187 miles above the Earth. He only did one lap around the Earth, but that became he was the first human to fly above the Earth. And he was become a hero all over the world. Here he's in England, and on the left side, then you can see this woman, very happy. She's actually the daughter of the Winston Churchill, the British Prime Minister. So this is 1961. So the race has begun. And then 1961, only just a few months later, not even 1 month, in May 1961, the American caught up. So American shown here is Alan Shepard. He became the second person to win above the Earth's atmosphere into space. So his was much shorter, only 15 minutes and only 116.5 miles, which is lower than the Russian record and shorter, but he became the first American to went to space. And then 1963, so there's a lot of activity in the 60s. So 1960, the Russian cosmonaut, Valentina, she became the first woman to actually travel to space. And she set a record of 70 hours in space. And for that amount of hours, she circled the Earth 48 times. So that everybody was very happy. She's the first woman to went to space. And then 1965, the races continue, really heating up. Another Russian. So as you can see, the Russian really leading this now. Alexei Leonov. He became the first human to conduct a spacewalk. He left the capsule in this spacecraft, and then he actually was tethered, connected by an umbilical cord, a line, but he was able to go outside it, free floating into space for 12 minutes and 9 seconds. Okay, so actually he became the first to do this, but it was not the last. This became a whole series of activity to see who can get to the moon. That's the next challenge. And the American, 1969, here shown is the famous Neil Armstrong and also Buzz Aldrin, the astronauts from the United States, on the Apollo 11 on July 20th, 1969. They became the first human to land on the moon. You can see the footprint on the right. So this was a very exciting time in the 60s. Remember what President Kennedy said, his famous quote before the American went to the moon. He said, "We did not do this because it was easy. We chose to do this because it was hard." So that was the mentality back in the 60s. We have the can-do attitude. So let's do it. We don't do a task because easy. We do it because hard. I hope you will remember that famous quote by President Kennedy and let that be one of your motto in life, okay? Always do something because in your passion, is in your dream, and don't do it because it's dream. The more difficult, the more interesting the challenge, okay? So 1984. So somehow between the 60s and the 70s, there was a slowdown in all the aviation, airplane design, aerospace, everything sort of slowed down. Even the 80s is slowed down quite a bit, and the 90s was slowing down. So the 60s was the golden era for space, and then for aerospace also. So even though there's some limited event happening, for example, 1984, the American Bruce McCandless, he became the first one to actually float outside the space untethered without connecting with any umbilical cord. And he did this from the space shuttle. So the space shuttle door was open. He was able to use a handheld nitrogen propelled backpack and was able to float into the sky out of 270 miles above the Earth. He was the first human to do that. And 1995, another decade later, we see another very exciting event. That was when the Russian cosmonaut, Valery Polyakov, he was able to stay in space for 437 days a year. That's more than a year, right? 365 days a year. He stayed and lived in space for more than 1 year. He set a record for that. And during his stay in the space, in this little home, just like your HGB apartment, he was visited by 12 different countries. He had many astronauts visited to the space station. And originally the space station was only going to last for 5 years, but it was so well built, actually was continued in service for 15 years. That's a very incredible engineering feat. And then the next one is the moon. We always know that back in 1969, even though the Americans had landed on the moon, but that was landing on the front side, facing the Earth. So let's take a look. What does it mean by the front side and the back side? So on the left side, we see the Earth. On the right side, we see the moon. We know that the moon goes around the Earth roughly every 30 days. That's how we get the lunar calendar, right? And that is how the Chinese calendars are based on. And we all celebrate in Singapore the Chinese New Year just not even a month ago, back in the beginning of the February, right? Because the Chinese calendar is based on the moon going around the Earth. So every roughly 30 days, it goes around the Earth once. And let's take a look. So when the moon goes around the Earth, the front side of the moon is always facing the Earth. So if you are an observer on Earth, when you look up into the sky, every time you see the moon, you always see the same view. So as the moon goes around, the face never changes. The moon always goes around it. So on the Earth, we can never see what is on the back side of the moon. So that's why sometimes we call it the dark side. So when all the American Apollo astronauts, like Neil Armstrong and Buzz Aldrin, they landed on the moon, they landed on the front side of the moon at a location called the Sea of Tranquility, because this allows you communication with the Earth directly, and also we can see what's happened. And no one had ever landed on the backside of the moon. And China, on January 3rd, 2019, set a record by launching a space vehicle, unmanned, became the first one to land on the backside of the moon. And this allowed us humans to be able to capture information, scientific knowledge that we never knew before. So that is another incredible feat. For this achievement, China received the Gold Medal Award from the Royal Aeronautics Society in 2020. Very impressive achievement. In 2021, the NASA made another amazing achievement. They were able to carry a helicopter all the way from the Earth to the Mars and flew this helicopter specifically designed for the Martian atmosphere on Mars, because we know the atmosphere in Mars is much lighter and less dense than on the Earth. So the helicopter need to be specifically designed to be able to fly in this very less dense air on Mars. And it need to be completely autonomous, because the communication, even by the speed of light, it takes many minutes for any signal to reach from Mars to Earth. So you cannot send a command from Earth and wait many minutes until the unmanned drone receives the signal. So this was completely designed by NASA to be able to land on the Mars after the spaceship land, unfold itself and fly on the Mars and send back signal and data and pictures and images to the Earth. That is a very amazing and incredible feat carried by the aerospace engineers. So in the last few years, we are seeing a complete new change now. Previously, it was a race between the countries, between the government. In the last few years, we have seen there's a new era of private space race. It's no longer funded by the government. It's completely 100% funded by private industry, private companies. The first one was SpaceX. It's a company completely private, successfully launched the space satellite. And SpaceX is a company that is owned by the famous Elon Musk of the Tesla car. So Elon Musk is what we call a serial entrepreneur. He has invented or opened up many businesses, including the Tesla car, SpaceX, the Boring Company, right? So he is really one of the inspirators that really help pushing the science and for people to invent. And since June 2010, after Elon Musk had founded his SpaceX company, he has privately launched his rocket 143 times. Out of those, 141 missions are completely successful. So that's more than 99% success. And the business model is, so SpaceX completely funded their own research and build the rockets, and then they allow companies, countries to rent space on their spaceship, the rocket, and to launch a satellite. And he has also set a record. They're able on one rocket, able to launch 64 satellites all in one shot. Even more amazing is, in the past, we always see the rocket ship, like the Apollo. They go to the space. The moment the booster, the launch, and then whatever the booster, the rocket, propellant, the base is all destroyed. But with the Falcon 9 rocket built by the SpaceX, they're able to reuse them for 10, 15, 20 times, because they will come back, like I showed this picture, and land automatically back on Earth. And exactly precise, you can see the circle on the ground. So that's extraordinary. You can have a rocket go to space and come back and land exactly the same place, all automatically. That's amazing. the race continued. So far there has been no private people, civilian, private company able to go to space. On July 11, 2021, the Virgin Galactic became the first private spaceship to send people to the space. It flew 53.5 miles above the Earth. And this was completely funded privately 100% by Mr. or Sir Richard Branson. Sir Richard Branson, he started his dream 17 years ago. And then he's so brave, so confident in his own rocket ship built by his company, Virgin Galactic. He became the first private person in space. He flew on the first flight of Virgin Galactic to the space. And you all know who Sir Richard Branson is. He also is a successful entrepreneur. He founded the Virgin Atlantic Airline, the Virgin Record, right? And he also does a lot of donation to the society to help the young people. The third billionaire, Jeff Bezos. He's famous for funding the Amazon.com, right? Him and Elon Musk are probably among the two richest billionaires in the world. But they don't just use their own money for their own use. They also reinvest all their money into space exploration and also to see how we can better make a future for everyone. In July 2021, so the company funded by Jeff Bezos, Blue Origin, and it's based in Seattle, Washington, United States. And I actually have my many classmates that actually work for Blue Origin. So it was successfully on July 2021, it went to launch the first spaceship that carries a private citizens. The trip lasts only 11 minutes. It went 65 miles above the Earth. The passenger, including an 82 years old and also an 18 years old high school student. It's extraordinary. These are all private citizens, are not trained astronauts. So one day in your lifetime, I'm sure you'll be able to fly into space also. Again, very amazingly, just like the Falcon 9 by Elon Musk, SpaceX, the Blue Origins are also able to land back on Earth requiring no parachute. That's extraordinary. This is even beyond what the NASA and the Russian, all the space agency can do. Now, here's a very famous actor, William Shatner, who played Captain Kirk in the Star Trek television show from the 1960s. This is when he was 1960. Today, Mr. Shatner is 90 years old. Guess what? William Shatner was invited by Jeff Bezos to fly on the second space launch in the Blue Origin. Here, you can see William Shatner, or Captain Kirk, was floating in the zero-G environment above the Earth. And he's 90 years old, and he's never trained as an astronaut. So this is a great time for everyone, for all of you, to be an aerospace engineer. There's a large demand, not like in the 80s, the 90s, the 2000s. It's very quiet, not much program. Now we have the government-funded research. We have also private companies. And so if you have the dream to fly or the dream to design your own aircraft, spacecraft, this is the best moment to become an aerospace engineer. And my motto to my students and the engineers that have worked for me for the last many years, I always tell them, if it can be dreamed, it can be built. And in the future, we'll probably see aircraft like this completely powered by electric, flying all over the skies. Today, in the last 10 years, we're seeing electric cars become popular. I believe electric aircraft is the future. That was my dream, to build an electric flying aircraft. So this picture in here is an electric aircraft I designed 12 years ago, back in 2010, that can fly forward like an airplane. It can take off vertically like a helicopter. So I started this back in 2010, and then I made many sketches and many drawings, and eventually we came out with this beautiful artistic shape, and then we said, let's build it. So I pulled together 30 young engineers, and we decided, let's do this, build it, and fly it. This is the finished product. You can see it looks just like the sketch. And this project was called the Project Zero. And here is the construction. You can see it's quite big. It's not a small model, not a small toy, made of completely carbon graphite. It's huge. It is about 12-meter wingspan from tip to tip. It can carry one person. It can take off vertically into a hover, and then the two big rotors can rotate 90 degrees and then flies forward like an airplane. And this shows the reference, how big is this aircraft. It's a 12-meter wingspan. And these are some of the, on the left, the team member. They just look like an astronaut ready to go on a mission. And we're able to successfully fly this. And this is completely 100% electric power, electric motor, running on just the same lithium battery like you use on your cell phone, your mobile phone, except a lot of batteries. And that was me. So basically here is back in over 10 years ago, preparing for the first flight of an electric vertical takeoff aircraft. And here you see it completely worked. And one of the things we decided to paint on the leading edge was leading the future. We decide this is going to lead the future. And today, there's so many companies and startups working on electric flying vehicle. In the next presentation by Dr. Neo, you will hear his dream and his ambition to build a completely electric flying car. So after we successfully achieved our target, so we decided to unveil the project. We took it to the famous Paris Air Show of 2013, and we showed off our project, AgustaWestland Project Zero aircraft. So if you want to learn more about it, you can just Google AgustaWestland Project Zero. You'll see many more videos. You learn more about this exciting project and dream of mine from 10 years ago. And this is some of the members of my small team. And then we won many awards for our innovation. And I'm very proud of all the engineers that work for us. That's why I said this is a great time for you to become an aerospace engineer. And finally, if it can be dreamed, it can be built. Thank you, everyone. Thank you.
Thank you, Dr. Wang, for inspiring our next generation of potential aerospace engineers and astronauts. Our next speaker is Dr. Neo. Is the founder and CEO of Neo Aeronautics, Singapore company that has built the personal aviation vehicle Crimson S8. He has designed aviation electronic system for military aircraft and has successfully launched deep tech ventures into MagTech, FinTech, GreenTech, and electronics. Dr. Neo will be sharing on the inventor's dream and entrepreneur's challenge in developing first Singapore flying machine, research, innovation, and entrepreneurship. Dr. Neo, please.
Hi, good afternoon, and thanks, Kok. And obviously, I'm very impressed by James, what he has done. Very impressive machine, and the concept of it can dream, it can build. And we all are dreamers, and but dreamers, beyond engineers, beyond dreaming, we are engineers, so we build at the same time. So I share my screen. You can see that I'm very much focused on innovation and entrepreneurship, and I play three roles as an engineer, first and foremost, because that's where we can create and invent stuff, and teaching like James. And obviously, I spend a lot more time setting up deep tech companies, applying the skills of engineering or STEM in entrepreneurship and businesses. I fly, so I got my flying license when I'm 20 years old, pretty young. Actually, I got my flying license before I got my driving license, and I got a powerboat license. So you can say I do air, sea, land at the same time. That's my son and my wife. And since I fly and engineering, so I can build, right? So that's where, same as James, but I try to also fly what I built as a flying car, or what we call urban aerial vehicle. Now, beyond that, I'm not just built from the aerospace, because with STEM, with engineering, you really can do a lot of stuff. This is a wearable dialysis machine, which is a 1 kilogram machine that I built way back in 2004 for the United States Veterans Affairs, like the ministries. And this is the 1 kilogram machine. And recently with my postdocs, I worked on the COVID-19, that we have 60 seconds diagnostics, non-invasive of what we call COVID-19 breathalyzer. And this is where the minister has tried it out. We need not actually go very, very leading edge. Of course, that will be interesting, but applying innovations, you can see that we built a smart helmet together with my students from Harvard, and that Ofra really loved it, and it became the 2018 Invention of the Year award. It's just LEDs that put inside the helmet, but it's trying to solve the problems of communication, and we did a crowdfunding campaign on Kickstarter, and you can see that within a month you get orders of $3 million US. So you can see that that's how we can apply our learning in STEM and engineering to solving everyday's life, and obviously from a helmet to maybe a car to, of course, going to space. And that's where I want to talk about the building of a global urban area community, which is like a group of people or communities that using flying cars instead of the urban aerial vehicle, which is like a mouthful. Flying car is something that everybody can understand. So this is the conceptual design of something like a Ferrari kind of sports flying car that we conceptualized a couple of years back. I started dreaming about it in 2010 when I was working in Silicon Valley, but I already actually started building in 2018. If you look at the next wave of the urban mobility, and I think this air show, there are a lot of news about Singapore having flying taxis, same as a flying car, just using it for commercial purpose in 2024. And you can see that actually there are many, many such versions from Volocopter, from Joby Aviation, and from Yihang in China. Most of them worth quite a bit. It's just a dream built. But of course, I focus a lot on the innovation and entrepreneurship of how we bring this into the market. Now, if you look at the NASA research report in 2018, it says, how big is this market? Well, if you look at the top right-hand corner, it's an unconstrained market. It's 500 billion. All right. So we are at the starting point of like the aeroplane in its earliest days. But even the aeroplanes in the earlier days, we look at the bottom part of the bottom right-hand corner. It says 2.5 billion annual market value, and this is only in the market size for the United States. Right? We're not talking about globally. This is the NASA research. And so the question is that when we are doing this flying car, where do we fly? Right? So NASA basically say, well, the urbanized center, like the city center, the centers, the downtown of Singapore, let's say the downtown San Francisco, these are a little bit difficult for us to fly around because of the urbanization, the number of buildings, high rise, and of course, lots of people. However, in suburban and big city where there are a lot more space and lesser tall buildings, those are the perfect place actually to start. And if we look at the report itself, it says that the airport shuttle and air taxi markets are really viable market even right now, with significant market values of about 500 billion in the future. And after applying operational constraints, which is like the airway, you need some controls, safety concerns. 0.5% of the total available market right now is about 2.5 billion, and that's 2018. So now it's probably more than $1 billion. However, there's really a lot of laws, constraints on regulatory certification. So building aircraft carry people or drones that carry people, really you have to think about safety, the hazards that can concern, not just to the flyer, but also the people who are in the flying path, right? And also the infrastructure, the weather, and maybe even noise, right? Environmental concerns. So those have to be sort of address. And in this NASA report, they say basically you really have to work with the local city government. So when we were building this company called the Neo Aeronautics a couple of years back, we started, so what's our strategies and what our vision? And being an entrepreneur, we really want to look at, if you build something, you want it to sell fast, right? Rather than trying to wait for the laws to pass. So we try to stick ourselves to existing federal laws and regulations, and there is this thing called FAA Part 103 ultralight regulations, which I'll talk about it later. And you look at the existing market and how you can turn it into everyday usage. So this is not an issue because NASA basically said, well, there's a market here. And obviously partnership with the government authorities. So based on these three strategies, we say, okay, we want to build a safe and reliable, and not just reliable, there's two most important things in any aircraft design, but also affordable. And affordable means not making it like a Ferrari, right? It may look like a Ferrari, but don't sell it like a Ferrari. So that every individuals and global communities can participate. So we have a motto, you know, everyone can fly. And then when I say everyone, I didn't mean one word, I say everyone. So it's two words. Every single person can fly. And of course, the vision is if you can build communities, then you want to broaden into the world. The question is, where does the regulations comes in? So if you look at the existing laws and regulation in FAA or the US FAA, it states that the ultralight vehicle, A, is used for manned operation. So if it's autonomous, then it doesn't fall under this law. And it's a single occupant. And this is the reason why when you look at my design, it's a single seat. It's never a double seat. Reason is very simple. No, I am a pilot. If I want to fetch people, you need a qualified pilot, and pilot training takes quite a bit of time, and not everybody can be suitable. So if we want to follow these operations or this design, is that a manned operation by a single occupant, single seat craft, and if it's intended for recreation or sport purpose, and then E section say if powered less than 254 pounds, about 125 kilograms. And it's not capable of more than 55 knots. That's about not more than 100 kilometers per hour. So it doesn't fly very fast. It doesn't weigh a lot. And it's a single person, manned operation, used for sports or recreation purposes. And what happened is that, notwithstanding this, the operators, we don't call them pilot because they don't have a license. The operators of the ultralight aircrafts are not required to meet any aeronautical knowledge, age, or experience, which means you don't really need a license to fly this craft. All right, so if there's such a craft that exists in the world that is FAA sort of give the license to fly, and they are actually. So there are three designs. The hover self is from Russia, the flyer, now not in operation, but in out of California, but it flies over the water. And then you have the blackfly. The blackfly actually flies over the so-called grassland. So the concept when I have come out is two concepts, right? One is for urban, where you can do transport between one place and another. The other is more sports, right? So you have a Crimson S8UM urban mobility and a Crimson S8-SR, which means for sports and recreation. Why Crimson? Well, if you understand Singapore history, we have this thing called the crimson sunbird, right? It's like a red color stuff, red color bird, but it's the unofficial Singapore national bird. So I just rename it crimson. All right, so S stands for Singapore 8. I think everybody understand, and that's the version of the model. So if you go for existing market and usage, then obviously I'm looking at the US where there is 1,000 chapters of 200,000 members who can fly, right? They are actually flyers, they have pilot license. But when you go to the market, you have to assess the risk, right? And the best is not get people who learn how to fly, have the flying license to get them to fly. And so unlikely there will be any accidents that happen, right? So this is the recreation model. And you can see that this recreation model is very interesting. It's a one car park space, so you can take off and land on one car park. And one of the things that you want to really focus on is not to change the infrastructure, right? Because you use the existing infrastructure. So one car park space, take off and land. You can see that there's this thing called a hot swappable power source. That means you can put in the batteries and you take it out, not like the crowd will sit there and then we start charging it for hours. So the design is very important, but the design and how the operationally being implemented and then how you operationally roll out is also critical. So engineering is not just talking about design, right? It's also about the operational aspect, integrating the business into it such that now it can roll out commercially. Science and engineering are quite different. Science is to find out the truth, to discover the nature, right? And engineering is to optimize it so that it can be deployed. And therefore, is a modular design, can be dismantled, put in the crate, ship anywhere. So everything is actually very simple. It flies like the drone. But one of the important things is recreational, right? So how you can then use it for tourists who may want to just fly above the Grand Canyon, take a look, then pass them to another place. So such possibilities are endless if you can franchise it based on the business model. And obviously, as what James said, eventually this thing will come to the cities. How is it going to come? I'm frankly not very sure in the next 5 years, but I think it'll be like a metro, it'll be fixed route rather than like taxi, you can just go anywhere you want in the city. I don't think that's possible. So I think the other important things about partnership, right? So we partner with, for example, the Utah states for the trials or commercial deployment. This pictures is taken in the last air show, the 2020 air show, where the U.S. Department of Defense Secretaries actually was trying out. And this is our Ferrari model, and this is our urban mobility model, and that's the team that built it. And you see that it's very small, it's very concise, and one seater, and that's the design that we have. And we're moving on to our generation 3 that we are going to look forward to certification eventually. Okay. And before that, James talked about space. I'm going to talk about space. Together with my friend, astronaut Jeff Williams, who's about to retire, he spent about 550 sort of days in space with about 5 spacewalks. I just have a sort of Zoom call with him this morning, talking about he coming for what we known as the Space Science Week in June. He'll spend 1 whole week in June, and you get to meet him personally, get the posters, autographed by him. But you can participate in order to do that, right? So we have what we call the space exploration journey on the left-hand corner. We have this right up. We have online course about rockets. We have online course about designing aircraft. I think one of the important things that will fire a dream is if you look at the just besides Jeff Williams, right? There's a space scientific contest. We would like to invite you, to dream. If it can be dreamed, it can be built, right? So we would like you to dream about what you're going to do in maybe next 5 years to next 10 years, where space tourism, right? And space voyages. So a space scientific contest. Write 1 or 2 pages, dream about it, write 1 or 2 pages and submit. All right, and you get prizes and you get to meet the NASA astronauts. So there are many things that we have. Just look at the QR code, go to the website, and you can participate in a lot of stuff. So so when people say the what they call, when there's a limit, there's no limit to what they call space, right? No limit to space, right? You got to go beyond space. All right, so I think that's all I have, and welcome to join us in all our events and activities, and look forward to see you.
Thank you, Dr. Neo. It has been certainly giving aspiring technopreneur quite a bit to think about. If you have any questions for the 2 speakers, feel free to drop them down into the chat box below together with your email, and we will then share with you their answers. We have come to the end of this STEM Check segment. Once again, I would like to thank Dr. Wang and Dr. Neo for their valuable time and precious advice given today. We look forward to hearing and learning more from both of them in the future. Before we come to the end of the AeroCampus live STEM Check, let us watch a video that showcases the highlights of the Singapore Air Show 2022. To our audience participating from the live streaming, thank you for spending your time on this Friday afternoon with us, and hope to see you again in our next Singapore Air Show AeroCampus 2024. Thank you.